So today we are going to do an introduction to Python and Jupyter Notebook. And so this is just an extension of the very beginner friendly one that we did. So we're just going to go ahead and get right into it. So if you want to watch the beginner friendly and then come back to this one, feel free to. So the first thing, if you remember what we're going to, is we are going to import our packages. So the packages that we need to use today are going to be NumPy, remember as NP, so we can easily refer it in the later cells. And just remember when you do packages, try to keep it simple. So use the ones that you only need for your code. So let's go ahead and run it. All right, so the next thing we're going to do is go over a loop again. And this time we're going to kind of introduce what it means to skip certain numbers, such as every second or every third. So for x in range, and then again, we need a beginning, a starting value, and an ending value. And remember, our ending value is always going to be n minus 1, so it'll be 11 minus 1, so essentially on 10. And then let's say we want every third number. We will go ahead and print our x. And so we should get, as we see here, 2, 5, and 8. Remember, when we're looking for a square root, we need to call on a package, and that's the same if we're looking for things such as pi or e. So we put np, so in our package, and we want the square root of, let's say, 2, run it, and there we go with the square root of 2. So now we can make it a little easier for us later on by defining a couple of variables that if we want to change, it'll be really easy to change. And then all we have to do is rerun the code later on. So this is kind of like our variables a little bit. So let's say we want to have a skipping value. So again, this is going to be for like our range. So let's say we want to skip every 2. Let's say we have a starting value equal to 0, and now we have an end value, our last value, which is going to equal 100. So we can run this, and this can just be the variables that we want to use right now. And again, it'll be a lot easier to change it later on in the code. All we have to do is just reset the variables and then rerun the code. So the first thing we're going to do right now is we're going to define so the first thing that I want to remind you is if we have, let's call our variable x1, or just this is going to be some sort of, let's say we want a list. So let's say I want my list in the range of start and our end value, and I want to do every 2, so we're also going to put skip. Now let's say I want to print x1, which should be a list, right? Wrong. What the print x1 is actually doing is it prints the literal context of our x1, which is what we gave it. So what we need to do is put our context into some sort of list. So now let's take x2, call list, which is going to take in the range our start value, our end value, and our skip. Now when we go ahead and print x2, we should see a list, which is now what we have. So another way that we can make a list, so now we're going to just pick something different. So new list 1, you can call this whatever you want to call it. This is just what I'm calling it. So we have I, and now we're going to square I for I in x1. So what are we doing? We're taking a value in I, squaring that, and we're saving it to a list. And this is going to do it for each value in x1. So now if we print new list 1, that is what we should get. As you can see, it took each of the numbers in that range, and what did it do? It squared each of those numbers and saved it into a new list. And then another way we can do this, so new list 2, is if we take I, again, we're squaring it for I in x2. And so it should do the same thing. Which we do have that. So as you can see, you can't just print x1. However, if you do it this way to create a list for X1, then it will be able to do it because now it's putting it into a list form compared to just printing just what you gave it. Now we are going to make a definition to easily find prime numbers from a list. So we are going to define, or we could call it, so we are going to test to see if a number is prime. All right, so remember for definition, it's DEF, and then we are going to give it a name. So let's say is prime for some number n. Now, if n is less than 2, meaning, which I won't type it on here, but you should type it on here. I can copy and paste for my thing. But if n is less than 2, meaning 1, 0, or negative numbers, we obviously know that it cannot be prime, so we will return false. Now, for I, so here we are using a loop within our definition. So once we got rid of all the 1, 0, and negatives, now we're moving on to I, for I in range 2, n. So right now, what we are doing is we are creating a loop for numbers 2 and greater, which we obviously know those can be prime. So if n mod I, remember that's for mod, equals 0, then, okay, so we know if n mod I is 0, then it is not prime because nothing can divide a prime number. So we would return this as false. And so for our last thing, we are going to return just our true values. So whatever is true is going to be the prime numbers that we want. So we run that. And then if we want to make a list of prime numbers using the definition that we just created, what we can do is we can make a list called primes1, which is going to be equal I for I in range. We can do 2n, which is what we named up there. If is prime, which is the definition we just gave, is I. So what this means is we're taking our i's from 2 to 100. If, and then we're running all those numbers through our definition is prime. If it comes back as true, that means it is a prime number. So we can go ahead and print our primes1, which should only be prime numbers. And if you look through it, yes, these are only prime numbers. So if we wanted to combine two things into a list to find certain numbers that qualify for what we're looking for, what we could do, so let's say we have primes 2. And so let's start with what we already know. So for I for I in range 2 to end. So if is prime, and let's say we want it in the form of 4n plus 1. So we could do I mod 4 equals 1. And then all we have to do is print our primes 2. And we would get prime numbers that are in the form of 4n plus 1. And I can write that here. So primes in the form of 4n plus 1. So you can do two things just by using an and statement there. And there's also ways that you can also use or statements as well, which we'll be using later on. So we can go over that when we do that. So now if we wanted to look at a loop that takes in a list that we give it that isn't number, so we can actually give a list of words, and this can be any words you want. So we could do apple, blue, oh my gosh, blueberry. We could even give it colors like green or yellow. And then what we could do is create a little loop. So for I in words, what we can do is we can say, let's print I but we only are looking at 1 through 3. So characters 1 and 2. 1 through 3, remember, our n is always n minus 1. So looking for characters, we're at the place at 1 and 2. So as you can see, we get from apple, we get P and P. From blueberry, we get L and U. From green, we get R and E. And then from yellow, we get E and L. And so now if we wanted to make a number a string and look at the first index, which is kind of what we did with those words. So if we have string, we have 1, 2, 3, 4, 5, 6. And let's say we wanted to look at the spot 0. That would just be 1. And what else you can do is int is actually integer. So if you wanted to, you could take your string 1, 2, 3, 4, 5, 6. You could make it, you could take the 1 index from string, turn it back into an integer, and you could square it, which as you can see, our first one is 2. Turn it into an integer, square it. That would be, so we can have number equals 1, 2, 3, 4, 5, 6. We could have letters equals string. So remember, a string is going to be letters or words essentially. And then if we want a list digits, we could have, so remember, int is going to be integers. So you could have I for I in letters. And then if we wanted to print our list digits, we could do so. So then we have this number. We're saying, okay, let's turn it into a string. And then we're actually going to turn each of those, each of the strings into integers. And then we can print that, which we can do. As you can see, now we have split them up. And then the last thing, if we wanted to have some digits, we can take sum, which is just going to add them all together, put our list of digits into it. Now that we converted it from a string back to an integer, and then we can print some digits, and then we get 21. And so that's just an intro into Python. Remember, we're just going over simple how to make definitions, how to do loops, and then also how to start doing lists, how to make lists, and also what you can do within lists.